Sup, students? It's your boy, Mr. Siegel, here to be doing two Regents problems with you today. They're a little tricky, but I think if we read through them, look for some clues, we're going to get the answers. So let's look at this first one over here. If you look at it, it says the base of a pyramid is a rectangle with a width of 6 centimeters and a length of 8 centimeters. Find in centimeters the height of the pyramid with a volume of 288. Well, I think a good place to start always is, well, what formula am I going to need to solve this? Well, I see the word pyramid over here, and I see the word volume over here. So it's probably going to be the volume of a pyramid. Now, you don't have to have this memorized. You could always look this up, but it's given to you on every book. So if you look it up, it's just the volume equals base times height divided by 3. Well, as you know, now we got to find what the base and height are. Well, the height's the easy one, but it's actually not given to us. That's what we're looking for. So we're just going to call that x for this problem, since we don't know what it is. Now, the base is always the area of the base. That's what we're trying to find, the area of the base. And if you read this, it says the base of a pyramid is a rectangle. So we're really looking for the area of a rectangle, which is just length times width. That's what's going to give us the area of the base. Well, it tells us that the length is 8 if we read the question, and the width is 6, and we know that's just going to be 48. Well, we got our numbers now. We can keep going to our problem. Well, if we keep reading the problem, it tells us what the volume is. It's actually given to us. So we could plug that in for V and just plug into our problem. So we go 288, which is V, is equal to the base, which is 48, times the height, all over 3. Oh, I know I said this was x, so let's just change that into an x. Okay. Now, how do we solve this? Well, what you got to do is simplify this side of the equation. The way to do that is actually just divide 48 by 3. And if you do that, you get 288 is equal to 16. Do that on a calculator and bring the x down. Finally, from here, I think you guys actually know how to solve it. All we got to do to get this out is not subtract, I hear that a lot, is divide the 16 on both sides. 288 divided by 16, I take out my calculator, and that gives me 18 is equal to x. X is therefore 18, and that means that is our height. Done and done. Just to repeat, you find your formula, you calculate your base and your height, and you can plug in your volume, and you just solve it from there. Let's go on to the next problem. Moving down, moving down. Oh, we got a picture here. Let's take a look. The cylindrical tank shown in the diagram below is to be painted. The tank is open at the top and the bottom does not need to be painted. Only the outside needs to be painted. Each can of paint covers 600 square feet. How many cans of paint must be purchased to complete the job? Whoa, that's rough. But, like I said, the first place we should always be doing is figuring out what formula we need. Well, we know it's a cylinder, so we're probably going to need a cylinder formula. But what do we need? Volume, surface area, or lateral area? Great question. Well, volume's for what's inside, and it says we're going to be painting the outside, so we probably don't need volume. That's out. And it also tells us that the tank is open at the top, and the bottom does not need to be painted. And what we remember is that the surface area is when we include the two bases, and the lateral area is when we don't include the bases. And in this problem, it's saying that we don't need to paint the top and bottom. So this would be a lateral area problem. So we look up our formula, once again just given to us in the formula sheet, and that's going to be, oh, sorry, that's wrong. We need the lateral area. There we go. So we just need to say the lateral area is going to be equal to 2 pi r times height. That's all. Now the only two things we have to figure out is what's the r, what's the h. Well, the radius is given to us right here, so we're just going to plug in 12 for that. And the height is given to us right here, which is 22. So now we just have to do is plug into our formula. So the lateral area is just going to be 2 times pi times 12 times 22. Now remember, for pi, we're just going to say pi is equal to 3.14 when we plug this into our calculator. Now, I'll do this along with you. Let's just go into our calculator. I'm typing it in. See if you could follow along. So what I'm putting in right now is just, let's see, calculator, 2 times 3.14 for pi times 12 times 22. If I get the lateral area here, you should have gotten 3,315.84. Well, the question here is not asking for the lateral area. You've actually done a lot of work, and I know these problems are complicated, but we're not done. The question is asking us how many cans of paint must be purchased to complete the job. Well, that's interesting. Well, what we know is each can of paint covers 600 square feet, and the lateral area is 3,315.84 square feet. So what do we do here? If this is the total area that we need to paint, and each can covers this much, 600 square feet, what we need to do finally is just divide it. So we're going to take this number, the lateral area, and divide that by 600, because that's how many cans of paint we'll need. So when I divide that, divided by 600, I need 5.5 cans of paint. Cans of paint. And that is all you need to do. Alright, if you need any help with these Regents problems, I'm always around to help you, and that is it for today.